So grab some highlighters. Try to move a little bit, right? Just move your arms a little bit. If you need to stand up once, stand up. You know, get your blood flowing a little bit. Periods are pretty long here, so trying to make it a little bit, get your blood flowing a little bit. All right, thank you. Type 0, regressions type 0, okay? So you're gonna do type 0, 1, 2, 3. And you're like, why are you doing that, Mr. Erickson? I kind of just compartmentalize them a little bit so you know how to approach them, because every question is a little different. Every type is a little different. So I don't know about you, but when I look at these questions and I'm like, whoa, what's this? Oh yeah, this looks like a type 0. How do you know it's type 0? It says it right here. Points are provided. The points are all given to you. You don't have to find a third point. You don't have to do any of that. It's just given to you. You will see this in grade 12 applied. I can guarantee you that. On the exam, they're going to have one of these on there. Maybe not a quadratic, but it will show up. So let's read this question. So an airplane performs a stunt at an air show. It consists of a sudden drop followed by a rapid increase in height. So it's kind of like a drop and then goes back up, right? That's kind of the idea here. The stunt ends when the plane reaches its initial altitude. So basically, if this is the initial, it goes down and comes back up. This is when the stunt ends, right? So start, end. This is just a little note on the side, right? The table below shows the heights at different times. So you have time and you have height. And I'll say something here. These may not be consistent, okay? These points may go up in various increments. You just take it, okay? You just take it the way it is. Don't make any changes. So I will make this my L1 always. You're guaranteed that the first is always going to be your X value, and the second row is going to be your L. We're going to enter that into L2, which we consider our Y values. Okay, so that's very important. We will never trick you. So let's say you have a table that is vertical like this. Let's use another pencil. A table that's vertical like this. This is X, this is Y, always, right? So we're never going to trick you that way. So make sure you understand that and you remember that. So determine the equation that models the height of the plane over time. Hey, you're supposed to model the equation, find an equation, find the regression, right? Perform a regression. So we're going to do that. So for A, we're going to go stat calc, and it's a quadratic regression. I'm going to give you a little foreshadow for grade 12. Okay, I'm going to give you a very helpful tool for grade 12. So watch this. I'm watching. Not impressed yet, right? Turn on plot 1, right? Because we're doing a regression. Plot 1 should be turned on. Do you remember what to enter these things? It's all in stat, right? By the way, this is we use this in statistics a lot. The spreadsheets, that's why it's under the statistics button, right? So stat, and then you edit, and then we're going to go in there and clear everything, right? You press clear and enter. And let's put in these values. So 2, enter, 6, enter, 8, enter, 15, enter. Then we go over to our L2, 750. You should do this, okay? Follow along, because, right, you pressing the buttons, if I show you, you'll forget. If I tell you, you might remember. But if you do it, it'll stick, right? So if you actually do it, it'll stick. And those of you that are doing your homework, I have a feeling that you would agree with me on that, right? Let's hit graph right now. We haven't performed a regression yet, right? Hit graph. Not impressed yet. Mr. Erickson, still not impressed. Go zoom. Remember the zoom that goes with this? Zoom stat. Zoom stat all the way there, the 9th. You see that? You should, in grade 12, we might ask you, hey, what would this be? Is this a quadratic? Is this a linear? What is this? And you should be able to tell, hey, this kind of looks like a quadratic. It looks like a parabola to me, right? So now we know it's going to be a quadratic. That's the only thing we're going to be doing in grade 11, all right? So let's perform a regression now. This is just a cool trick to tell what kind of regression are we supposed to do. So we're going to go stat, calculate, we go quadratic regression. And remember this step? Second 1, comma, second 2. So you're telling it quadratic regression, go and get L1 and L2. And then comma, I told you the shortcut is alpha trace. And we're going to put this into Y1. I'm just going to tell you this. When I key these things, when I key and I do a bunch of homework questions, I may have stuff in L1 and L2 for one question, and then I'll use L2 and L3 and L4 for a different question, L5. So I have them all in my spreadsheet. So I kind of use this differently when I do a different question. I'll say, no, I want you to go to L3 and L4 for this one and put this into Y2, right? So you can, if you want, have multiple rows going. If you don't want to erase everything, if you want to have it right there to just use it again down the road. I'm just giving you a helpful hint here. But for the most part, you're going to use L1, L2, Y1, hit enter, and there's your equation. Okay, so let's write that down. And because this is a regression, we're going to go with y is equal to, you go 9.375. I'm going to use 3 decimals. Why, Mr. Dixon? Just because I feel like it, right? There are instances where if you round to 2 decimals, you end up with 0. 0, 0. It's not good enough. Then you for sure have to go 3rd decimal. All right, guys? That happens sometimes that this a value is really small. And as long as you round correctly, more than 2 is all right. As long as you do that correctly. So this is 750. So we're just going to do that plus 1080.00. So we're just going to leave it like that. So this is the equation. And you might wonder, I think you should at least wonder, is like, wait a minute, A is positive. It's pointing up. Does it make sense? Well, when I read the question, I interpreted the question this way. So it does make sense that A is positive, right? Okay, so just always think critically. Don't just take it face value, because if you make a mistake, you should be able to catch it, right? What's the initial height of the plane at the start of the stunt? So we'll do B here. I will say y-intercept gives this info. Okay, so 0C. It's in general form. All of the regressions are always in general form. So it's 0, 1080. Therefore, initial height is 1080. What are we measuring it in? We're measuring it in feet. Okay. There we have it. So we didn't even need to, I'm just going to box that in like that. That's B right there. How long did the stunt last? How long did the stunt last? How would we do that one? I'm going to do that here, C. Starts at time 0, right? Ends at time question mark, right? That's what they're asking you. So the way we're going to do this is knowing that it ends when it reaches the initial height. We're going to say, well, let's figure out, right, when y is equal to 1080, what is going to be the x value there, which we know is our time. So let's go ahead and do that. y2 is equal to 1080. And then we hit graph. And this isn't a really good graph. I mean, it gets you started, but we will change our window a little bit, okay? Careful here. I always recommend to be able to see your y-axis and the x-axis, right? So to see the y-axis, we need to bring this further to the left. I'm going to go -5 with my x-min. And the y-min, what happens there? Sorry. Delete. The y-min, I'm going to go just below, just -5 or something like that for the y-min. Okay, that's almost like my go-to right away. X-min -5, y-min -5. And if you hit graph right now, you should be able to see, like you see the x-axis and you see the y-axis. But you still don't see much else. We need to see 1080, right? Minimum. So we're going to go window and y max. I'm going to change that to maybe 1100, 1200, 1500, whatever you want, just bigger than 1080. Let's hit graph. Okay, so I see that. Another change would be x max, right? Let's change that. And you might find it frustrating that I do it this way, but that's most likely what's going to happen to you, right? Don't change too many things at the same time unless you know exactly what you're after. So, oh, sorry, window, I went to 30 for X max. Just tried it. Hit graph, and now you can see most of the things, right? No x-intercepts here. I just want to clarify that. It doesn't cross the x-axis. So let's go find this intersect here. We know that this is 0,080. We're going to figure out what this is. So second trace 5. Enter, enter, enter. And so that is 19.599, which is 19.60, right? So 1960,080, right? And because we start at time 0, we don't need to subtract here. We don't need to do the delta t, right? It would be irrelevant. So time would be 19.60 seconds, right? That's what the time, that's what we're after. It takes 19.60 seconds to perform the stunt. So from initial height, dipping down back to 1080 takes us approximately 1960. I have to say approximately because this is just a model, right? The calculator models based on the points that are there. Okay. All right. D. What's the plane's lowest height? How would you find that lowest height? The vertex, right? So the vertex is right here. Please don't do some students do trace and then they'll just, oh, when I trace, I can't do that actually, but don't do the cursor thing, kind of hover over it. Just find the vertex, right? Find vertex. I'm actually telling you what I'm doing, right? So I'm going to go second trace min, right? So I need you to understand we're still doing word problems. The only difference with this one to the ones we've done before is that we need to come up with our own equation. That's the only difference. Second trace min. Let's go to the left of the vertex. hit enter, go to the right of it, hit enter, and then enter one more time. So that is 9.79, which rounds to 80, 179.63. By the way, the vertex is going to come in handy when you graph it, so you better write down the coordinate, right? Because then you have it already. You don't need to find it again. So we would have to say that this, right, this is time, and this is height. Always remember that. How do you know? Let's go back to the beginning, right? Time went into X, height went into Y. Therefore, we know this, okay? So lowest height is 179.63 feet. I'm going to warn you already, if you have Miss Yosek, you might want a longer sentence. Just so you know. Just do what she says, okay? Don't say, Mr. Dirksen allowed us to do this. That's not going to fly, right? Just do whatever she says. Okay, E, graph the scenario. Ooh, did I record that? Anyways, she'll never know. The province is all right with just putting down time, a number, units. The province is all right with that. Like, they just want to know, do you understand how this is supposed to be done? Okay, so let's graph it. I'm looking at my time. I need to tell you this. Some students on the provincial exam use these points to graph. There's nothing wrong with that in and of itself. But sometimes it's so incomplete, you don't have a vertex, you don't have the intercept, so it's not quite exactly what the province would like. They want to see where's the y-intercept, where's the vertex, all of those points as well. So if you want to use these to guide you, by all means do that. But I will just stick with the plan here. So this is time. Let's just get rid of the labeling issue, right? So time and seconds. And then this is height in feet. So we won't lose marks there. And somewhere here, let's add the equation already. 9.375 x squared minus 183.75 x plus 1080. Okay, let's just do that. Let's not lose marks for labeling. And now we need our scale. We know that the stunt ends 19.6 seconds, right, after the initial drop. So if we can fit 20 in here, we're doing pretty good. So I'm gonna go 5 here, 10, 15, 20. That works pretty good. And just for good measure, I'm gonna go 25. Right, so consistent, and this is there. You have no excuse to not be consistent here, right? I gave you a grid. And then the y-axis, we need to have, what's the highest number we need to reach? 1080, right? 1080. So let's try things. 200, 400, 600, 800, 1000, 1200. So if I label, right, if I do 200, 400, 600, that works out for me. Okay, that works out for me. Could you have used 300? Absolutely. Could you have used 100? You would have been in trouble, right? If you used 100. So you got to kind of like make it work with the space you have. And let's go ahead and do this. 1080, think about this way. This would be 1100 because it's halfway, right? And then I just drop a little bit and put the 1080 right there. I'm going to go find 1960, which is very close to 20. I'm going to go up the 20 line, and I'm going to line it up with the initial height because that's kind of a given, right? Oh, sorry, it's not right on the 20 line, sorry. It's just slightly over. Don't make it touch the 20. They are picky, like the province would be picky with that. If it's ballpark, very close, that is good enough, right? And then our vertex, 9.8, which is very close to 10. 179. So let's see here. This would be 100. This would be 150. So 179 is somewhere here, just shy of the 10 mark. Just shy of the 10 mark. And here you have everything you need. You don't have your x-intercepts, right? So what acts as a x-intercept for me right now? These 2 points act as the x-intercepts normally when it's pointing down, right? So you kind of have a reference. So let's try this. I'm going to start with my vertex and curve it a bit and go up like that and do the same thing here. Boom. You have a beautiful graph. You get full marks. Perfect. You're going to do a lot of graphing with me, but you're going to be good at it when we're done, and I want you to be good at it. And I model it a lot, so you won't have excuses. Well, you only showed us once or twice. I actually do a lot of modeling. Like ACs, when I mark it, I try to actually graph it with you, not just like, here it is. Did you get it? No, mark it wrong. Like, I want you to see how I do it. Because it is tricky. Graphing is not easy, but there's certain things that you can like pick up on to make it work for every situation. Right? F, domain and range. Oh, you know what? I need more space. I'm gonna use my space wisely here. I'm gonna do the F right here. So this was E here for the graph. All right, what's the domain and range? Can you take a risk and figure out the domain and range just yourself right now? And if it's wrong, we erase it. Big deal, big deal. Just take a risk right now. What would be the domain and range for you right now based on this work problem? Take 2 minutes. You're smarter than you think. Remember that. All right, ready? Domain is times 0 because you're thinking time, right? Times 0. So you see graph, right? If you travel along the x-axis, you keep seeing graph until 20. No, not 20. It's 19.6, right? That is your domain. That's the time restriction. That's a restriction, guys. We're putting restrictions on our graphs to make it work for us, because otherwise it goes to infinity, right? Both ways. Range goes from the lowest height here, which is, I know that's 179.63, all the way to the highest point of this scenario, right? It's this scenario, which is 1080. All right, so always lowest first, highest second, always, right? Make sure you get that right, because sometimes students get the right numbers, but they don't put them in the right order, and that's very important to get it right. I will do set notation as well, just because some people prefer that, and there's nothing wrong with that. And you can use x and y because that's what we use for our equation. But if you're given an equation, you got to use the letters in the equation to come up with your domain and range. I know it's weird, but that's how we roll. Sometimes you just don't argue. Okay. Some of you get flashbacks, right? That's what your parents or guardians or whoever you live with tells you, right? How long was the plane at or above 800 feet? This one is tricky. This one is worth 2 marks usually. Well, let's start with this. We were given a height, so we're going to go ahead and find those points. Let's go ahead and do that. So y equals, I'm going to clear that and replace y2 with 800. And here you see that it happens twice. Within our domain and range, it crosses it twice. So there you have to do a delta t scenario. So we'll go that our first point, let's find the first one. Second trace 5. Let's find this one right there. So the first instance, first time is 1.6. Okay, here's something. Did I mention the 4 decimal thing? Yeah, I'm going to do 4 decimals here because we're not done yet. Like, this is not going to be our final answer. This is part of our answer. Second time this happens, second trace 5. And that's why I like the videos, because I know right now you're just writing down. Like, I need to write this down. But then the videos, sometimes you just need to go back to this point. So round to 4 decimals, then you're making sure you're not going to get a round early error. Okay. So it happens twice, right? I'm going to do this. This is the 800 line. And so this is the first instance. And this is the second instance, right? So it happens twice. So what is it asking for? At or above, right? So we are interested in these sections right here. We're interested in how long did you spend here and how long did you spend there. If you do delta t in this case, you have to be very careful. You would go 17.9346 minus 1.6653. And what do you get there? You get, watch this, 16.2693 seconds. What have you just found when you subtract that? Did you find above or below? Time above or time below? And the answer is, if you subtract these two, you're actually finding this chunk right here. Because you're saying, hey, this happened first and then this. So if you subtract these times, you are finding time below. This is below. But it's part of your answer though. And I know this is tricky. I know some of you might have a hard time wrapping your head around this, but when you subtract, you find the arc. Think of it this way. When you subtract, you find the arc. So this could be like this or like this, but that's what you're finding. So time above, watch this, and then I'm done. Time above is total time for the stunt minus 16.2693, and that is 3.33 seconds. This is what we're after. Circle it. That's what we're after. I just have 2 questions. So homework, page 50 to 51. They're basically 2 big questions. Please do at least one. At least one. Do one. Because I will AC you on regression on this type tomorrow, okay? So be ready for that. I need you to get on top of this, all right? Thank you, guys.